we get started, are there any questions over the homework? Any questions on any of the homework assignments? Now, especially with our 731, when we're multiplying or dividing, once we factored, you don't have to multiply back out. Just as a reminder, because there's not a whole lot of reason to have it, once we have it factored down, to multiply back out. Because if you get an answer, I'm just... something like this here, leave it. There's no real reason to multiply the top and bottom back out, because it is simplified. Really, that's not making it more simplified than leaving it this here, because this is going to be the same answer as 6. I mean, there's no reason to expand it back out if we have the exact same answer. So, for our multiplication division, leave it here. Or even with our addition subtraction, when we start adding or subtracting, once we have it in factor form, there's no reason to multiply it back out of it. Now, where we left off yesterday was finding the least common multiple. This is, I think, where we stopped. So, we did finish that one? Okay. Yes, because I had to add it back in. So, again, we're finding this least common multiple to be able to add or subtract fractions with unlike denominators. And to find this least common multiple, we're going to take our two expressions here and factor them down as far as we can so that we can see the factors and look at the factors of the two together. Now, our 6x squared minus 54 has a greatest common factor of what? 6. So the first thing we can do is factor the 6. When we factor 6 out, our 6x squared becomes x squared. Our 54 becomes 9. So now we just need to factor the x squared minus 9. Now, x squared minus 9 does factor nicely because it is a difference of perfect squares. So we'd have x plus 3 and x minus 3. Now we know for certain, so least common multiple, we're going to have x plus 3 and x minus 3 at least once. They showed up once in this one for each one, so we're going to need it at least once. Let's factor the other one, 9x squared minus 54x plus 81. There is a greatest common factor of 9. That's so since there's a greatest common factor of 9, we factor it out, leaving us with x squared minus 6x plus 9. Third term's positive, so the signs are the same and match the sign of the middle term. Negative, negative. Factors of x squared. Factors of 9. 3 and 3. And if we do check this here, x times negative 3 would be negative 3x. Negative 3 times x is negative 3x, giving us the negative 6x that we wanted for our middle term. And these two here are completely factored, which means we can go about finding our least common multiple. Do we want to find the least common multiple between 6 and 9 first, or our sets of parentheses? Because it doesn't matter which one we do first, we'll have to find them both eventually. We can do 6 and 9. Now, 6 and 9, 18, 24, 9, 18, okay. Luckily, 6 and 9 are small and very close together, so doing the skip counting or the factorization will get us there at about the same pace. So 18. Well, let's start with the one on the left. X plus 3. The one on the left has one factor, set of factors for x plus 3. How many does the one on the right have? None. We don't have any x plus 3s. So how many times does x plus 3 show up in either? Once. So how many times do we need it? Once. Now let's look at x minus 3. For the one on the left here, x minus 3 shows up as a factor how many times? Once. Yes? Let's look at the other one. It shows up how many times over here? Twice. So which one has the most? The second one, the one on the left, yes? How many x minus 3s does it have? 2. Even though this one has 1, this one over here has 2, so we take 2 of them. We look at whichever one has the most sets of that factor and take that many. So yes, x minus 3 does show up 3 times between the two, but because the one on the right had it twice, we take 2 of them. Because again, we're trying to get them to be the same. So yes, they do both have it once, so it will show up once, but because it showed up a second time over here, we need it twice. Does that make sense? Yes? Because again, we're trying to find the term or expression to get these to be the same, so we can get the denominators to be the same. And know what we have to do to be able to turn both of these into this expression, this first expression that they'll be the same. Because for here to turn 6 into 18, we need to multiply it by 30, because 30 times 6 would give us 18. Our 9, to turn it to 18, we need to multiply it by 2. So the 18 would be covered with that. The one on the left, x plus 3 times x minus 3. What is this missing that this has? It's x minus 3, so we'd have to multiply by x minus 3. The one on the right does have x minus 3 and x minus 3 twice, but it's missing in x plus 3. So really, this one on the right is being multiplied by 2 times x plus 3. To get them to be the same, I have it written split up. And over here, we're multiplying this one by 3 times x minus 3, just to get them to be the same. A lot of stuff everywhere. Again, I'm moving on just so it's getting a little disorganized. But it's figuring out what's going to make them be the same. What's the first term? And the reason that getting this least common multiple is more important with this than just numbers are easy to simplify. Variables make things a little bit more challenging. Let's look at the last one of finding least common multiple before we move on to actually adding and subtracting. 5x cubed. Anything we can do with it? No, it's one term. There's one thing. We can't do anything with it. 10x squared minus 15x. Is their greatest common factor? 5x. Now, if we factor 5x out of 10x squared, we're left with 2x. We're dividing it. 10 divided by 5 is 2. X squared divided by x at x. 15 divided by 5 is 3. And the x factors out completely. Least common multiple. Okay, I'm going to start with 5. This one has how many 5s? 1. This one has how many 5s? So how many do we need in the least common multiple? 1. Okay. This one here has x to the third. This one has x. So over here, how many x's do we have? How many do we have in the other one? How many should we have total? 3. It's very tempting to want to say 4. It's just 3. Because one of them has 3, so to get them to be the same, we need them to both have 3. Does that make sense? Questions on this here? Again, if anything doesn't make sense, this is now the time to try to address it. Because it might seem that we're trying to group them. Why don't we group them all together? Well, this one has 3 x's. This one has 1, yes? If I multiply that x by 2 more x's, we would get x to the third. They're now the same. That's why we're going to have 3, not 4. All right. Anything else with this term here that's left? No, we got everything, yes? What's the only thing missing? X minus 3. That's it. Questions on this here? All right, we're ready to start actually adding, subtracting. Find the sum of 7 over 9x squared plus x over 3x squared plus 3x. Before we start adding, or actually adding and subtracting these here, we are going to need to first off get the denominators to be the same. Because 9x squared and 3x squared plus 3x are not the same. Not by a long shot. So we need to get them to be the same. And before we can do that and really focus on doing that, I would highly advise factoring those bottoms, factoring the denominators as far as they can go so that we can find the least common multiple. Or in this case, the least common denominator because we're doing it for the bottoms of the fractions. Now, 9x squared is a single term. Nothing we can do with it. It's a single term. We can't factor it any farther than what it is. Let's look at the other one, 3x squared plus 3x. First place we always should be looking is greatest common factor. There is a common factor of 3x. And if we factor this 3x out of 3x squared, we're left with x plus. Questions on this here so far? So we need to get them to be the same, yes? Because if we can get these two denominators to be the same, then we can add and subtract the numerators, or here add the numerators together. So off to the side we can say least common multiple. So we're trying to find it between 9x squared and our 3x times x plus 1. So first thing we can look at is the least common multiple between 3 and 9. Trying to find the first number we can turn both 3 and 9 into. It is actually indeed just 9. Because if we look at the factors of 3, 3, 6, 9, 12, 15, factors of 9 are 9, well, that works out nicely. Next thing we have is our x squared and x. So the one has 2 x's, the other has 1. So how many x's do we need? 2. So the next part of our least common multiple, what we need to turn these denominators into is going to be x squared. So 9x squared. Which is pretty much everything from the one on the left. The one on the right is missing the what? We still have that factor of x plus 1. So our least common multiple, in our case, least common denominator, because it's going to be on the bottom of the fraction, it's the denominator, is 9x squared times x plus 1. Because if we can get both of those to be that, then we can add these together. Anything above this will work, but we'll have to pull out additional factors at the end. It will simplify at the end. Questions on what we've done so far? Okay. So the goal at this point, send that down, is to go from having just 9x squared to have 9x squared times x plus 1, and to go from 3x times x plus 1 to 9x squared times x plus 1, to get these to be the same. All right, let's get a highlighter. So, the left, we have 9x squared, yes? So we do have that part of that denominator already there. What are we missing? The x plus 1, yes? Because it does have the 9x squared, a part of our least common denominator. It's missing the x plus 1. Now to get that added to it, what we're going to do is we're going to multiply this rational expression by 1. Well, a fancy version of 1. Because what I'm going to do is I'm going to multiply, that is, I don't need the calligraphy pen, is I need to multiply the 9x squared by x plus 1. But I'm not just going to multiply it on bottom, I'm also going to multiply it on top. Because anything divided by itself is 1. So really, what are we multiplying this by? 1, which is a fancy version of 1. Because if we do this, the bottom 9x squared times our x plus 1 will give us exactly what we want. Now let's look at the other side. Now we have the x plus 1. That already matches up completely. However, we don't have the 9x squared. We have 3x. So we need to multiply this on top and bottom by something that would take it from 3x to 9x squared, which will be 3x. All right, guys. Because here, 3x times our 3x, because since they're not inside parentheses, we can multiply them in front. 3x times 3x, 3 times 3 is 9. X times x is our 9x squared. So we have the denominators the same. Now we need to multiply the numerators. So on the left here, we're going to have our 7 times x plus 1. On the right, we have our x times 3x, which is 3x squared. Questions on this here? Because when we add, and we're going to add these together, we're going to have to combine like terms, yes? So is there a possibility that multiplying that 7 times x plus 1 will give us like terms? Yes and no. Most likely not, at least in this case, but there is a chance when we're adding and subtracting, we might have to combine like terms. So we do have to multiply through the top. So here we're going to have to distribute the 7. 7 times x is 7x. 7 times 1 is 7. Now, we don't necessarily need to do that with the bottom of the fraction. There's not a whole lot of reason to. Because if something's going to simplify and we multiplied it through, we're going to have to factor it back out. Because it's either going to match up with the 9x squared or the x plus 1. Now, when we add these together, we'd add our first term to our second. But this here, we really don't need the parentheses. Telling us that we have 3x squared plus 7x plus 7 in standard form. Questions on how we got to this point here? Now at this point here, we need to make sure this doesn't factor, that 3x, specifically 3x squared plus 7x plus 7, doesn't factor. Guys. Okay, because I can wait. Here, 3x squared plus 7x plus 7. If it factors, we need to factor it. If it doesn't, we're going to leave it alone. Even if it, because what we're looking at making sure is that one of the factors is not x plus 1. Because if one of the factors is x plus 1, it simplifies, we need to reduce it. Now, it doesn't look like there's a good chance this will factor. Because again, if we're going to factor it, we'll have our two sets of parentheses. We need to check the factors of the first term and third term and go through that whole process. Now again, we do have a way to check to make sure something does factor. And that comes from our quadratic formula. Specifically, we don't need the whole thing. I just need the square root of our b squared minus 4ac. Because if the number that comes out of this here with this quadratic ends up being a non-decimal number, a real number, then it tells us that our 3x squared plus 7x plus 7 factors. So here, our b value is 7, because again, it's coming from our ax squared plus bx plus c, minus 4. Our a term is 3, and our c term is 7. So we're just looking at the square root of 7 squared minus 4 times 3 times 7. Which tells us that we have a domain error. If we ever get an error, this means that our radical here is going to end up with I. It's going to have imaginary solutions, which means 3x squared plus 7x plus 7 doesn't factor. So this here is our final answer. That's as far as we can take it. So since it doesn't factor, we can't reduce it. Questions on this here? All right. We're going to look at the next one. We're going to find the sum of 8 over 12x squared plus x over x squared plus x. Yes. Now we need to make sure we factor both denominators as far as they can possibly go before we find the least common denominator, this least common multiple for the bottoms of these fractions. Yes, that would make a very big difference. 12x squared is a single term. We can't factor it. We can't simplify it. It's as simplified as it gets. X squared plus x does have a greatest common factor of x. And if we factor it out of the x squared plus x, we get x times x plus 1. Least common denominator, or least common multiple for these here. And what we're trying to match up is our 12x squared and our x times x plus 1. So the first thing we can do is look at the terms in front of our parentheses. Well, for one, the 12x squared doesn't have any parentheses. It's just 12x squared. So we're trying to match up the 12, and well, the number in front of x is 1. So we know for certain that we're going to have the 12. Our next term outside the parentheses is x squared and x. One of them we have x squared. We've got 2 x's. The other we have 1. So it's going to end up being x squared because we need 2 x's in both of them. Since one of them had 2 of them, both of them are going to have 2 of them. So that takes care of the one on the left. The one on the right, the only other factor that it has that both are going to need is the x plus 1. So for us to be able to add or subtract these, we need the denominators to be at least 12x squared times x plus 1. It could be bigger, but that's going to cause us to have to simplify more. So now we're going to need to see what we need to multiply both of these by to get our denominators to match, for them to be the same. So for the one on the right, we do already have the 12x squared matching. The only thing we're missing is the x plus 1 on top and bottom. So we're going to have to multiply the top and bottom by x plus 1. The one on the right has the x plus 1 already. We have an x, but we don't need an x to the first. We need it to be x squared. It's missing an x. So on top and bottom, we're going to have to multiply this by x. And it's also missing the 12, so we're going to have to multiply it on top and bottom by 12x. And we're doing this here on both of the denominators, both of the bottoms of the fractions. We do get the 12x squared times x plus 1, which does give us these two denominators, which are the same. Now again, the numerators we're going to need to multiply out. And luckily for us here, we could have done this on the last one. We can actually multiply this since we don't have too many terms, too many expressions going on. Because here we have x times 12x, which indeed will be 12x squared. On the left-hand side, our x plus 1 times 8. 8 times x plus 1. 8 times x is 8x. 8 times 1 is plus 8. Questions on this here before we start adding these two together? Now it is seem interesting, on the one on the right we do have 12x squared on top and bottom, yes? It can factor out, but the reason we're not going to is because if we do, I'm going to erase it for now, because those cancel out, because that would reduce us to 1 over x plus 1, yes? Are the denominators still the same? No, because one's 12x squared times x plus 1, and the other's just x plus 1. We can no longer add them together because the denominators aren't the same. So there are some places where doing a reduction first, and each one is fine, because as long as we can keep those denominators the same, it works. But here we have to keep that 12x squared because we need them to both have denominators of 12x squared times our x plus 1. Does that make sense? Now at this point here we can add the numerators. So we have 8x plus 8 plus 12x squared. Since we're adding, we could put the parentheses around them, but it's not going to have a big impact because, again, addition is not so much necessary. Our subtraction, we've got to be paying very close attention to our signs. Because we have to distribute that negative through the numerator of what we're subtracting. Now, before we can call this finished, we do need to see if we can factor the numerator. So, always look for a greatest common factor first. Is there a greatest common factor between 12x squared, 8x, and 8? they all have a common factor of 4, which leaves us with 3x squared plus 2x plus 2 over 12x squared times x plus 1. Now we need to, from here we can see if 3x squared plus 2x plus 2 will factor. Since the third term's positive, signs are the same and they're going to match that middle term. So most likely this isn't going to work. Because if this is going to work, the middle term should either be 7x or 5x. And we can check this for sure with our square root of b squared minus 4 AC and see what we get. Second square root of 2 squared minus 4 times 3 times 2 is another domain error. So really it's saying we're taking the square root of 20, so our answers 2i square root of 5. They're not only imaginary because of the I, but they're also irrational because of the square root of 5. So that tells us that the 3x squared plus 2x plus 2 is as factored and it's simplified as far as it's going to go. So that part's taken care of. However, this is not fully simplified. 4 over 12. Because again, that's a multiplication. It's outside the parentheses. We can simplify that. Because 12 and 4 have a common factor of 4. If I factor the 4 out on top, it factors out completely on top, leaving us with our 3x squared plus 2x plus 2. It factors out of our 12, reducing it from 12 to 3, leaving us with 3x squared times x plus 1. And that's what we're left with here. Questions on this here? And I think as we're starting to notice with a lot of this addition subtraction, it's not that there's a decent bit to it stepwise, but a lot of it's going back to factoring, going back to being able to factor the top and bottom, get them to match, add or subtract, and then simplify down. So questions on this here? Okay. We'll finish this tomorrow.